What's up, guys, and welcome. Today we're going to be doing the proof for the Pythagorean theorem, which is a theory about right angle triangles. If you have a triangle A, B with sides A, B, and C, then the square of the longest side is equal to the sum of the squares of the other two sides, obviously. And and if you have the longest side A, then a squared plus b squared is, or rather, a squared is equal to b squared plus c squared. So yeah, let's get into it. We have here two squares, so you can see them. We have the bigger square and the smaller square, and of course the bigger square has sides b plus c, and the smaller square has sides a. And yeah, we can start here and say, well, the area of the small square, which is this one here, is of course simply a times a, which is a squared. Well, the area of the bigger square, which is this one here, has dimensions b plus c, so it's b plus c plus, times b plus c, which gives you this b squared plus c squared plus 2bc. Now, of course, if we go back to this big square and look at it broadly, we can see that it is made up of the small square. The area of the big square is made up of the small square, and it is also made up of the four triangles, which is triangle 1, 2, 3, and 4. Of course, these four triangles are congruent to one another, as you can see, and of course they are congruent because they have all three sides equal in all triangles. Therefore they are congruent, and they are right angled, and of course they are also scalene, so they make up a rectangle when put together. To take up, say, triangle 1 and you put it together with triangle 2, they will make up a rectangle with dimensions b and c. So here is the rectangle here. So here triangle 1 and triangle 2 make up this rectangle with dimensions b and c, and triangle 3 and triangle 4 also the same. Now, of course, the area of triangle 1 plus the area of triangle 2 is equal to the area of the rectangle, which I've labeled R here. The area of rectangle R being b times c, or just bc. Likewise, the area of triangle 3 plus the area of triangle 4 simply equals the area of this rectangle, which I've labeled P, and which is of course also equals to B times C, which is BC. Of course, the area of triangle 1 plus the area of triangle 2, 3, and 4 simply equals to BC plus BC, which is of course 2BC. Of course, going back to our bigger square, we can see that the bigger square, as we've already said, is made up of the small square and plus the four triangles, which have an area of 2bc. Therefore, the small square, which is this one on the diagram, is of course equals to the bigger square subtract the area of the triangles. And see here, you can see that small square equals big square minus this. Small square is a squared, of course, and this is the area of the bigger square. Subtracting the area of the four triangles, we end up with a squared is equals to b squared plus c squared, which is true. Of course, if you go back to this diagram, you can clearly see here that if you strip away the four triangles, from the big rectangle you end up with the small, rather from the bigger square you end up with the small square. So it's true. The four triangles are congruent. You strip them away. You are stripping away an area equal to BC. Then you end up with A squared. You strip away the area of B.